Assalamualaikum warahmatullahi wabarakatuh. I would like to welcome the presence of Dr. Muhammad AFIF bin AYOB, panel 1, and ENCIK Muhammad FADZLI bin SHAIB as the second panel. This is a presentation for my final year project 1 entitled Hybrid Soft Robot Hand under the supervision of Dr. Muhammad NAJIB bin RIBUAN. My name is Rahmat bin Busura and my metric number is CE170097. First of all, I want to make a little explanation about the background of study. Okay. So, what is robot hand? Robot hand is an effector attached to an industrial robot arm or human limb as specific hand to perform any desired task such as welding, gripping, and spinning, depending on the application that we need. Robot hand has been manufactured for the last couple years, adopting the adaptability remain constrained because of the complexity and were hard and unfriendly robot. This issue leading to non-compliance and non-dexterity robot hands. Okay, as you can see here, this is the example of robot hand. So, what is hard robot hand? A hard robot hand manufactures each part on each hand using 3D printed material with mechanism parts such to perform each finger's movement. Okay, as we can see here, the robot hand is built from the hard material and the mechanical part also in like spring and gear to build in the robot hand. Okay, the robot hand is category with three classes, which is low, middle, and advanced. So what is soft robot hand? Soft robot hand is the soft of robustly grasping and identifying object using internal strain and force measurement as well. Built from soft materials such as silicone, elastic, rubber, and plastic. As you can see here, the soft robot hand also have classes like low of manufacturing, middle of manufacturing, and advanced of manufacturing. Okay, we move to the application of soft robot hand. There is so many soft robot hand around the world. As we can see here, this is the most popular soft robot hand that human use. As we can see here, the cable-driven soft robot surgical system for medical purposes, and warehouse industry for a factory, and then the artificial hand for a disabled person. Now, the application of hard robot hand. What is the main use for hard robot hand? As we can see here, the most popular is for the disabled person. Okay, as we know, Japan is the technology's country in the world. Okay, they built the Asimo robot. As we can see here, the robot hand is applied. Okay. Also in industrial purposes, like the German did. They put the hand at the arm. Okay. So the problem statement is, here is my problem statement. What is non-compliance and non-dexterity hand? So I will show you here. Okay, as we can see here, the robot hand just move like static movement, so there is no smooth movement at the finger, at the wrist, and it's only in one direction. So this problem is very hard to grip the object at the arm, at the hand. So if the robot hand still can hold the object but not grasp enough. So here is the main problem and the example of non-compliance and non-dexterity hand. Okay. Next. The previously is non-compliant. So here, what is compliance and dexterity robot? Now, can you see this?
We're trying to build robots
This is the
that
example
learn
of compliance
a little bit
and
like humans do,
dexterity robot.
by trial and error. What we've done is trained an algorithm to solve the Rubik's Cube one-handed with a robotic hand,
Okay.
which is actually pretty hard even for a human to
The
do.
finger movement so smooth like human
We don't
hand.
tell it how the hand needs
They
to move
learn
the
from
cube in order to get there.
Human
The
hand
particular friction that's on the fingers,
movement
how easy it
is
is to turn the
very
faces on the cube, what the
compliance
gravity,
and
what the weight of the
dexterous.
cube is. All of these things, it needs to learn by itself.
The object
The interesting thing is that
is
kind of
very
standard techniques in robotics
stable in the
haven't been
hand.
able to scale to that
So
complexity that we see in a robotic hand. Humans
can
have
grasp
evolved
and
to
hold the
be able
object
to
very strong
manipulate and
enough.
operate our hands. So there's a huge amount of learning that's happened through evolution to get us to this point as a species. And the robot has to learn all of this from scratch. Instead of trying to write very dedicated algorithms to operate such a hand, we took a different approach where we create thousands of different simulated environments and learn to do the task in all of those, and hopefully a robotic hand will be able to do it in the real world as well. This means like thousands of years of experience that this neural network has had in simulation. Every time the algorithm has gotten good at the task, we make the task harder. That's really crucial because it needs exposure to really complicated environments in order to eventually be robust to the real world. You put a rubber glove on the hand and can still carry out the task. This ability to generalize to new environments feels
Okay,
like
as
a
you can see
very
here,
core piece of intelligence.
how strong it is.
It really changes the
to
way
hold the
we
object.
think about training general purpose robots. Moving from thinking too much about the actual
The
algorithms
hand is very delicate.
and start
to
thinking about
handle
how do we
things
create
like
complex enough worlds
playing
where they
cube
can learn.
or others.
At some point, then it would be more down to the imagination what robots could actually accomplish. The hope is to build robots that can do many different tasks to increase the standard of living and give everybody a better life.
The dexterity robot hand is a smooth movement hand like human hand, but this Shadows project is use more complex mechanism, and the main program is using artificial intelligence, which is AI. The focus in my project is to make the robot hand is robust, compliance, smooth movement. So the difference is the shadow is using the complex programming, but in my project only basic mechanical movement, but the compliance and dexterity is the same. So the objective of my project is to investigate the mechanical properties of soft material to achieve the compliant hybrid soft robot hand. Second one is to study the mechanism of hybrid soft robot hand actuation to achieve the delicate response and human-like hand motion. The third one is to evaluate the soft robot hand performance in terms of compliance and dexterity. And then the scopes is the mechanism properties of soft raw material will be tested for its compatibility with the combination of hard and soft robot hand. Second one is the construction, fabrication, design, assembling hybrid soft robot hand will be focused on tendon mechanism to be applied on the rigid and soft material. Finally, the complete prototype will be tested using dexterity test. As we can see here, existing robot hand. First thing first, the Delta Bionic. Here is the detail. This is invented by Saujana Ahmad Rajab in local Malaysia. The non-governmental organization NGO developer. So he developed this hand in 2017. The mechanism properties, tendon line connected to the servo motor in palm. Here, in the palm here, use gear at the finger. In every finger has a gear as the mechanical movement. The design issue is this robot hand is fully rigid 3D printed and complex design with mechanical part. And the other is no wrist rotation, just static movement of at the wrist, and it is quite heavy. Okay. This is more advanced if compared to the Delta Bionic, which is the Bionic 3. Mechanism properties, tendon line connected to servo motor in palm, use metal part finger joint. They are fully rigid for the design issue. Okay, as we can see here, there are no soft material here. A lot of 100% of rigid material and complex design with mechanical pump and also heavy. The shadow robot hand, the very intelligent hand, mechanism properties, servo motor in 4 out, use 38 wire synthetic fiber lining, use spring connected to the tendon, and high cost complex mechanical design using spring, no grips at the palm and only have at the end finger. Continue to the soft robot hand, which is RBO hand 2. So the design issue is very slippery when dealing with lot over 77 pounds. It's 34.9 to 66 kilogram, no rigid part, comfortable for short object. This is also from soft robot hand M grip. Then the design issue is no reinforcement support from the rigid material. This is fully soft material. Methodology in this final year project 1 is start from phase 1, which is collecting or data collecting of rigid hand and soft material, and then study the suitable soft material and proceed to the phase 2, which is design the model with compliant and dexterity properties using SolidWorks. Okay, and then phase 3, which is conducted in final year 2, is start to fabricate in 3D printing design, and then the phase 4 is attach the soft material with the 3D printing. So the rigid hand and the soft material is combined in this phase to make it hybrid, and if it match, the several dexterity tests will be conducted after all the hand is complete the attachment. So this is the dexterity test. Design modeling, I'm using the SolidWorks software. This 3D printer use the Ender 3 3D printer, the servo motor and fishing line for actuation movement, and the tendon attached to the finger. Result, this is the design for final year project 1. This the dimension of a hand is the same with the human hand at the right here design, and the wrist, the hole here for a tendon line which is connected to the finger, called the soft finger. Then the focus is 90-degree bend of each finger connection. So the design of wrist joint, this is the model 1. As we can see here, using shaft, the mechanism properties is using shaft as a rod to be placed at the both of palm, here, and end of the arm joint. This is arm joint, connect together with shaft. So for model 2, a little bit improvement from model 1. The shape of the ball designed for the ball, which is soft material here on the arm. The shaft can make also 180 degree of pitch movement. The third model is more improved of model 1 and model 2. Use a spring on the material ball parts, able to perform with pitch yaw movement and more flexible characteristic. So for the conclusion, this is such preliminary conclusion for final year 1 has achieved the first objective by producing the pre-designed model hybrid soft robot hand in terms of mechanical properties of soft material. The hybrid model has almost achieved the mechanism for hybrid soft robot hand actuation to achieve the delicate response and human-like hand motion. However, this model design must be improved in mechanical characteristic, especially on the wrist. So the design of the wrist is still in progress. Fabrication of prototype hybrid soft robot hand in 3D printed will be manufactured in FYP2. The recommendation for this project is optimizing the robot hand's shape, especially on the mechanical properties, but not too complex and reduced weight of hybrid soft robot hand. Second is to improve the hybrid soft and rigid hand design so that to achieve the estimate human like hand movement. Here I have attached the Gantt chart. Here is the plan for final year project 2. For the reference, here is several reference article that I am used to in this research, and that's all from me. Thank you.